Civil and Environmental Engineering Materials Lab. This is the lab that we use for our undergraduate class to teach students how to test various materials we use in civil infrastructure. So things such as wood, steel, concrete, and plastics. This is a machine known as the Universal Testing Machine, and we use it for a number of purposes in this lab and for this class. Right now it's set up to apply compressive forces, or in other words, to squish things. So most recently we had a lab on testing the properties of wood as you apply this compressive load. So we would have taken a sample like this and either oriented it vertically or horizontally, and then we would have placed it between those two plates, and then measured the amount of force it takes to fail the sample. So in this case here we have a sample that we compressed vertically. You can see how it failed. Here's one that we actually tested horizontally. You can actually compare sort of the size difference. We were able to basically squish the sample by half. Then once we removed the load, it actually did rebound a little bit. We can also set up this machine to apply what's known as tensile forces, or to pull things apart. So for instance, we can test samples such as steel. Here's a section of steel reinforcement, otherwise known as rebar. This is what we typically will find in reinforced concrete structures. So we will replace the two plates with grips that would grip onto the ends and pull it apart. Similarly, we also do experiments with plastics. So this is a sample of what's known as high-density polyethylene. This is pretty much what is in your grocery bags. Okay? So here's the original size of the sample, and now you can compare it to actually pulling it, and it actually never even failed. It actually ran into the limits of the machine, and it never actually failed. We can now actually make some engineering assumptions about that based on these types of performances. Alright, so this is a test setup we have to measure the amount of energy it takes to break a steel sample. So here we have a sample of common carbon steel that we will commonly use in civil engineering applications. Now, how this is set up is we have this hammer that's set to a specific height, so it has a known amount of energy right now. When we take our sample and we place it at the bottom and align it, right? What we're going to do is now release this hammer, so it has a known amount of potential energy that will convert to kinetic energy, and then some of that energy will go into breaking the sample. So right now, with the hammer set up here, we have a known energy of 300 foot-pounds, and now we can actually release the hammer. And we can see that it took about 230 foot-pounds to basically break this sample. And we can actually even see that this sample of steel didn't in fact even break, but it pretty much just deformed. And so now we can use this to make engineering decisions about this material. And we'll also run this at different temperatures to know the temperature dependency of this material. An important material we use in civil infrastructure is concrete. So in fact, concrete is the most used man-made building material in the world. Currently the world produces about 28 billion tons of concrete every single year. So with a vitally important material such as this, we spend a lot of time in this lab and in this class testing the properties of concrete. Now, what concrete is very good for is for compressive loads. That's why we use it in things such as building columns and walls. So what this test does is this measures the amount of strength that concrete has when we load it in compression, or in other words, squish it to death. And in fact, we would get failures such as this. High-strength concrete will actually even explode because it has such high strength. Now, one of the other things we test in this lab are the flexural properties of wood. In other words, the bending properties of wood. So in this test setup, we have a beam configuration for a piece of 2x4. Took a piece of 2x4 and just cut it into smaller pieces. And now what this does is we have it fixed on the two ends, and then we apply a load vertically in the middle. And we measure how much strength the material has as we bend it until it breaks. We can actually see there's quite a number of cracks and failures through that sample right now. And this then gives us engineering properties for how we will test wood, how we will use wood in civil infrastructure, and in what orientations. So this machine right here is known as a fatigue test. So fatigue is when you have a sample that will fail even at applied loads less than the material strength. So for instance, if you take a paper clip and constantly bend it back and forth, back and forth, back and forth, you're not breaking the paper clip, right? But that repeated bending, it eventually does fail. That's a failure known as fatigue. Now what this test does is it takes a cylindrical sample like this, and what it does is we apply a very slight bend to it, and then we rotate it at very high speeds. So that slight bend to it is applying a stress that is going to be fatiguing the material. And what happens is we turn it on. Let's close this first. Turn it on. And now it's just going to apply a number of repeated loads very, 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 very quickly. And now eventually the sample is loaded in here, you can see. It will eventually, in fact, break in half. And now we can make engineering decisions based on how much bending force we applied and how many cycles it rotated until it broke. So I encourage you to come study civil engineering at Virginia Tech. In particular, come take this class where we test the material properties of all the materials we use in civil infrastructure. This allows us the capability to actually build and engineer our world. So we get to test things such as concrete, wood, steels, and plastics in this lab, and it allows you to learn how we can further engineer the future.
All right, so we have a question on how often is a lab renovated and where are classes held when that occurs. So this lab was actually recently renovated. Let's see, it was renovated in 2016 or 2017. So most of the equipment in this lab right now is fairly new. And in fact, a lot of the testing machines are still fairly new. So when it gets renovated, when they've renovated this lab, we basically moved all the machinery to another space, and we still held the lab, um, just in an alternative space with less capability. Um, but now that this lab's renovated, we'll probably be using this space for quite a number of years before it needs renovation again. How far is the lab from campus? So this lab here is on campus. Um, so this lab is primarily used for teaching. So we have a number of classes in here that come to do labs. Uh, Mostly testing what was presented in the video. We do have additional lab facilities a little bit um, off campus, and that's where we do kind of much larger structural scale lab testing. And that's more for research. We do have undergraduate research out there as well, but classes usually don't go out that far to that lab. All right, so we have a question on how many labs are there on campus. Um, if you wouldn't mind clarifying that question, are you referring to um, labs such as this for classes or just labs in general for all majors? These types of labs. So this lab facility here is for the Department of Civil Engineering. So this is lab space mostly used by the civil engineering department, but then also construction. There are similar labs like this. There's one, in fact, right next door that some of the other departments use. So mechanical engineering and material science engineering. They do a similar class to this one, where they're testing material properties, but they don't focus on the civil infrastructure materials. So we test things such as concrete for this class, whereas mechanical engineering, material science, um, they're not as interested in concrete. So they don't have the facilities to test concrete there. But so there's this one, there's one next door, and there's probably a few others in other departments that undergraduate lab classes will use. So how many students are in a lab class? What is the ratio of student to teacher? So that is a bit of a difficult question to answer because it varies depending on the class and depending on the department. I can talk about this class because this is the class I teach, right? So this semester we have, let's see, we have 112 students in this lab class this semester. Um, it is 12 students per lab section, and we have 10 sections. And then each um, lab section is run by uh, two teaching assistants, and then sometimes me as well. So in that case, the instructor to student ratio in the lab is 1 to 12. Other semesters it's 1 to 16. And then the lecture is, pretty much 1 to 112, just because we are a fairly large department. Now, as for other lab classes, I can't really speak to that. If you're asking about things such as general chemistry or intro to biology or things like that, that I'm not certain. So that you'd have to look at those other classes. But the other lab classes in the department, so we have another lab class that focuses on um, fluid dynamics, so how fluids flow, water flow, things like that. We have another one on soils and geotechnical engineering. So we test like the engineering properties of rock, soil, sand, things like that. And those classes, I'm not certain, but I believe they have similar ratios to this materials lab class. And then we do have, so this lab class is offered to sophomores and juniors. We do have upper level lab classes where there are even fewer students. So for instance, next semester I'll teach a class for, it's mostly juniors and seniors, and there's usually about 20, 25 students in the class. And then a graduate class for students pursuing a master's or a PhD, and that's usually maybe upwards of 5 students in the class. So hopefully that answers the question. Let me know if you have any follow-ups about that. Um, so I'm going to skip over the one question because there's a related question here that says, how big are the class sizes? Um, and again, all I can say is that does vary depending on the major, depending on the class. We do have, if we look at something like general chemistry, yeah, there's a lot of students that take that class, right? Because it needs to be offered to so many majors. So I don't really know what the actual size is. But again, all I can do is speak to the classes that I offer, that I teach, and that varies depending on the level. Um, I'm teaching another class this semester on, it's called Computer Applications, and it basically just talks about introductory coding and things like that. That class this semester has 60 students, um, and that class actually has, I believe, 4 different sections this semester, and each of those sections has somewhere about 60 students. Um, so we do have classes that, depending on how they're taught, we offer multiple sections to keep the classes a bit smaller. But then other classes, we just have to have a large classroom setting, just because of the amount of people that have to take the class. And then as you go to kind of upper level courses, those class sizes tend to shrink as you focus a bit more. Okay, so we have so yeah, if there's any follow-ups to those questions on class sizes, I'm happy to answer. But now we had another question on what kind of labs projects do the civil engineering majors do? Um, so in civil engineering, we actually have these sort of subdisciplines, we can call them. All right, so in this lab, we're mostly focusing on the materials side of civil engineering. So this is where we're testing all materials we find in civil engineering. So concrete, wood, plastics, steel, aluminum, uh, asphalts as well. What else do we have? I think that's all of them. Um, Other subdisciplines we have structural engineering. We then also have environmental engineering. We have geotechnical engineering, so that's things like soils. We also have water systems. So that's everything dealing with water, lakes, rivers, things like that. We have construction management, and let's see, and then we have transportation. All right, so we have these different sort of sub-disciplines, and the civil engineering majors will take courses in most, if not all, of those sub-disciplines. And then as they get to, later in their undergraduate career, junior, senior level, they start to focus on something they find more interesting. So, the question of what kind of labs projects do civil engineering majors have, it depends a little bit on what you're interested in, because then you can kind of focus. So um, we have three main labs in the department, and undergraduates have to take, I believe it's two of the three. So we have this one on materials, we have the one on fluids, and then we have one in geotechnical. Okay. Um, and so let's see, in the fluids class, they're testing things like, water flow. How does the, shape of a water channel change velocity and flow? How does the roughness of a pipe change that sort of flow? Things like that. The geotechnical lab, they'd be focusing on things like shear strength of soils. How well is the soil going to stand up to loading? How do the soil properties change due to water or other additives? Things like that. Um, and so those are the primary labs in our department that the majority of our undergraduates take. Um, like most engineering majors, they also will have to take things like general chemistry. So there's labs associated with that. General physics, labs associated with that as well. Um, and that should be most of the labs. There might be a lab associated with introductory geology. And then I know this is a long-winded question because it's a bit open-ended, so I apologize. This is way more information than you wanted. Um, but then, of course, in all of our classes, even if it's not a lab-based course, we will have projects in that class. Um, and those projects will be based on what is the focus of the class. So if we have um, a class on roadway design, all right, you'll have to have a project at the end of the semester on designing a roadway structure, or designing um, the shape, the curvature of the road, things like that, the geometric properties, right? How do you know how quickly to turn, things like that? You have to design all of that. um, let's see, so in courses, like I teach another class that focuses on concrete materials, and particularly how things essentially fall apart in civil infrastructure. So one of the projects the students work on there um, is something called forensic engineering, where they have a case study where something's going wrong. All right, we're seeing, let's say, cracking in a bridge, or we're seeing part of a concrete column falling apart. And part of their project then is coming up with methods to test in the field to figure out what's going on. And once we know what's going on, we can come up with a plan on how to fix it. Okay. So the biggest thing that civil engineers are trying to do is basically the betterment of society, right? So how do we make, um, for instance, I'm in infrastructure, right? How do we make the infrastructure stay in place, right? How do we ensure that our roads aren't falling apart? How do we ensure that our bridges aren't falling down? Things like that. And so um, labs and class projects will all relate somehow, to those topics in my classes. And then again, in these other subdisciplines, you focus on something else. So hopefully that, I know there's a lot of information there, so I apologize. It was more information than desired. But hopefully that gives you a little bit of information of what you were looking for. If you have any follow-up questions, just let me know. Okay, so we have a question on the civil engineering major work with CoOp. Yeah, we do have that as an option. Um, I don't know how many students are currently using it because of the pandemic, but yes, we do have options for co-op where you can essentially take a semester off and go work and get some credit for that. So yes, we do have that. And then the other thing is probably the vast majority of our undergraduate students um, do also have summer internships. So the civil engineers in our department and from Virginia Tech are in very high demand in the state, right? And also just around the region, right? So all the nearby states. I think it's something like, I think the statistics I heard is that 50% of all civil engineers in the state of Virginia came from Virginia Tech, right? So we have a lot of alumni, um, and they like to keep Virginia Tech students at their companies. So a lot of our students get a lot of offers for summer internships, summer projects, and that it's actually a really, really good opportunity to do anything like that. We have another question. Co-op isn't required for graduation, not in our department. I know there are other universities that do require a co-op for graduation. We do not. That is not a requirement here. Um, Pretty much at VT, you meet coursework requirements, and then you graduate. Are there research projects in your department? So are you wondering about just general projects we're currently working on, or if there are undergraduate options for research? Do you want to clarify undergraduate options? Yeah, absolutely. So I currently have one undergraduate student working in my research group. In the past, I've had two others that have worked in my lab. Um, some faculty members will have a lot of projects. Um, I would say that there's always an option for undergraduate research. You can get course credit, for instance. So instead of, let's say, taking course X, right, you can also get credit by doing research in the lab. So the way it works in our department is, you would find someone, one of the faculty members that does something you're interested in. You go talk to them and say, "Hey, I'm interested in helping out in the lab. What can I do?" Um, and we say, "Sure, let's try and figure out a project." And so some students will um, just like to volunteer and go in the lab and just see what's going on, so they get a sense of what research is. We have other students that will take research credit. So they basically, do a number of hours of research every week. So instead of a class, they're spending more time doing research in the lab, and then you get course credit. Um, and then we have other students that prefer to get paid. All right, so that is also an option. So the one undergraduate student in my lab right now is an hourly employee. So he gets paid by the hour to help conduct research. So, it really depends. You have to find a topic you're interested in, um, a topic that can be done for, typically a few hours a week if it's during the semester. And then you find a faculty member who likes the idea and will work on it with you. Um, so I think, undergraduate research is highly encouraged. And if people are interested, then it's probably always an option. You just have to find where to go. And then we also have a number of undergraduates that will get hired for the summer, right? So some undergraduates will, go take an internship for the summer. We've had other undergraduates that will stay at VT for the summer and essentially work as an hourly employee on a research project. And that's nice because over the summer, if you're not taking classes, you have a lot of time. You can dedicate a lot of time to do a project like that. And the nice thing about civil engineering is you can almost apply it to any field. Um, so if you're interested in civil engineering, but you're still also interested in um, Well, okay, let's look at my case. So um, I more or less work in a field that blends civil engineering, material science, uh, geochemistry. Um, we'll probably leave it at that. So it's kind of blending a couple of different fields, but I would say I'm still a civil engineer. Okay, um, I was just able to find a focus that really caught my attention. So actually, when I was an undergrad, I started in civil engineering. Um, I toyed with the idea of switching to physics. I toyed with the idea of switching to material science. Um, and then what ended up in my career was I kind of just found a path that led me in that direction with research, with other with other jobs I've held that basically put me in a field that aligns with everything I like, right? So I'm still a civil engineer, but I kind of blend in these other fields. Um, so we have other civil engineers that work in more environmental science, and they may be blending chemistry, or they may be blending in more biology, right? So uh, there's a lot you can try and blend in to civil engineering. Um, even if it's not just civil, specifically, right? That there's a lot to go to. So civil and mechanical, that's another one that can have quite a bit of overlap. Um, civil engineering, if you're looking at something like structural engineering, basically trying to design, uh, the components of a building. What's going to hold this building up? How thick do we have to build this? The beams here around the room, these columns. Um, and civil engineers and mechanical engineers will take a lot of very similar courses on mechanics to understand how things like that work. All right, so mechanical engineer might be applying those principles to um, so some sort of machinery, robotics, something like that. Civil engineers were taking those same ideas and applying them to buildings and structures. Civil, mechanical, electrical. So that's an interesting combination. So here again, I'll say you can probably find a way to blend those. And I'll give you an example. It is 3D printing of concrete. That is a hot topic right now. Civil engineering is really starting to focus on this idea of 3D printing, and one of the topics is 3D printing of concrete. That's starting to gain more attention. So you can be a civil engineer and focus on the material side. You can be a mechanical engineer, focus on the robotics, and then you can be, an electrical engineer, focusing on a lot of the probably the electronic design. Again, ways to blend probably everything with civil engineering. See, so someone's asking about 3D printing of concrete. Yeah, so that's actually a um, so 3D printing of concrete is a hot topic right now. Um, it's still mostly in I would say a sort of research phase. We we've seen a few companies in the field that have built something out of it. Um, but the basic idea is when you're building with concrete, if you know people may not have ever really worked with concrete before, maybe not, but it's like a liquidy material when you first mix it. All right, so you mix essentially cement powder, rock, sand, and water. You mix that all together. Um, it's kind of liquidy and it's castable. You can make something out of it. All right, and you would fill some sort of mold. In the case of 3D printing, the beauty there is you don't need those sort of molds to cast the concrete in. So you would have essentially a fairly sort of stiff mix that would basically just go along and start moving around and printing a shape. I can try and see if I can find an interesting video real quick. 'Cause, yeah, there usually is some pretty cool stuff we can do with that. Yeah, we can see what this is. Don't exactly know which video this is, but we can see what they're printing here. Let's do share screen. All right, let's see what we got printing here. All right. Let's see. There we go. Now they're printing something. So, anyways, that's just sort of a quick. We don't have to watch that whole video, but um, yeah, I mean that a lot of people are thinking that's the future of civil engineering is that sort of technology, with the idea being you basically can move this robot to a field, wherever you're going to be building something, um, and you set it up to just be automated. You would have machinery that automatically mixes the concrete, pumps it to the robot arm that prints everything, and now you have very little labor involved, right? So you can save quite a bit of money there. Um, it can be lower cost materials. It can be now faster construction. So whether or not this is the wave of the future, I don't know, but yeah, it seems it's really gaining a lot of interest. It's something we're actually trying to get some projects here at VT to do as well. Um, and because one of the other good things about VT is we have some researchers in mechanical engineering that are at the forefront of 3D printing. All right, they're forefront of 3D printing, plastics, metals, things like that. So trying to join forces, right, and use their knowledge on the robotics, our knowledge of the materials, and see if we can print something. Um, there's other projects around the country I've heard of. For instance, there's one lab that's looking at um, 3D printing um, containment. If there's this is actually for nuclear power plants. So if there's a meltdown or something or an accident at a nuclear power plant, instead of risking the lives of people to go in and try and build some sort of structure around it to contain the radiation, you would have a 3D printer that now can build a wall or something around it. People are also looking at 3D printing on the moon or Mars, right? So now you just, instead of sending a manned crew to the moon, right, you send a few robots to the moon to build the structures in preparation for astronauts to settle. So there's a lot of pretty cool things going on in that world of 3D printing, but um, nothing is quite ready for application, I would say. Of course, that being said, there are companies out there that are currently, printing buildings. We just don't have enough information, I argue, on um, how durable are they? Are they meeting design codes? Things like that. That's something we still have to work out. But yeah, we'll see where that goes in the coming years. Civil engineers are in very high demand. Um, it has been a growing field for a number of years. Um, so I forget the exact numbers, but we have a fairly high job rate upon graduation. Something like, I think it's well over 90% of our students have a job within 6 months or so of graduating. So and it's usually a fairly well-paying job for that as well. Okay, so we have a question here on, is there a senior project? Okay, so that's a good question. In civil engineering, we don't have kind of a capstone senior design project. A lot of departments do that. In our department here, instead, what we do is we have a number of design classes, and in each one of those design classes, you have a sort of capstone semester design project. Um, so if you have a course on pavement design, so designing a roadway structure, you'll probably have some sort of capstone project on, here's some real world conditions. How would you design this? All right, so that's a little bit different how we do it in our department. Um, So instead of kind of one big year-long project, you have a number of semester-long smaller projects. Okay, so someone says they're interested in civil engineering because it's not as specialized as construction management. And and yeah, I mean there's we definitely have an excellent construction program here at VT as well. Um, with civil engineering, what is nice is we do have this department with these sort of subdisciplines, right? So um, you get exposed to a number of these different disciplines, and then towards your junior senior year, you get to pick other areas that you're interested in. Okay, so you don't have to specialize, but you can if you discover that hey, I'm really interested in foundation design, so I'm going to take more courses in that. Um, and there are civil engineers out there that essentially become a jack of all trades. That was actually a summer internship I had in, let's see, that was between my junior and senior, no, sophomore and junior year. I had an internship, um, where the guy I worked for was basically the civil engineer manager for this entire property, and it was a laboratory facility. They had something like 300 acres. I don't know, probably 60 buildings, 10 miles of roads on the facility, and he was in charge of anything and everything related to civil engineering. So if there was a problem with the roads, they'd call him. If there was a problem with the sewage system, they'd call him. If there was a problem with an environmental spill, they call him. Something with the soils, they call him. So he basically had to know a little bit about every aspect of civil engineering. Now that's not everyone, right? I just always thought that was kind of a cool job because you know every day was not the same. Every day was something new. Uh, so I guess it kind of keeps you on your toes. And then there's other people that do civil engineering, and then they'll get a job in a fairly specialized field, right? But if that's something you're interested in, something you're excited about, then you know, uh, then definitely do that. The best advice I can always give people is, I know it's cliched, but like what you do, and you'll never work a day in your life, right? And so, I love my job. I love coming to work. I love working with students. I love doing research. I love teaching classes. It's a lot of fun, right? And every day is different. And I would say that can be for civil engineers, right? You can find jobs that you get to do a little bit of everything. Let's see. So someone is asking, are there specific minors for civil engineering? Um, so depends on how you're phrasing that question. You don't get a minor in civil engineering if that's what you're asking. But as a civil engineering major, you can get minors in other fields. Um, so, for instance, yes, there's probably a minor. So, someone's asking about urban planning right now. So, yeah, there's probably a minor. I believe there's a minor in urban planning. There's a minor in green design. Um, there's more minors coming out in things like sustainability, sustainable engineering, or sustainable materials. Um, so, there's a lot of options for minors if you want to do that. Um, and I don't even know what the statistic is. We do have students that do minors. I don't think it's as high as 50%, but yeah, I would say that a number of students do consider minors. All right, we have a question on, are there classes on urban planning? Um, so I'm not the person to ask that. That's not related to my field. So I don't know the exact answer. In our department, no, but I think a lot of our students take classes in other departments for urban planning. Um, so that is of interest. We have a number of faculty in transportation engineering, particularly people who look at things like transit, traffic, things like that. they're tied in fairly well with urban planning, right? So how would you plan, a transit system, to optimize for an urban setting? So yes, there are courses in it. There are courses you can take to satisfy the degree requirements for civil engineering, and I believe there's a minor for it as well, but I'm not 100% certain on that since that's not quite my field of work. I mean, I can tell you how I got here. I mean, I always when I was younger, I always liked architecture. Um, I was fairly fascinated by buildings, and I decided that I didn't want to do architecture. Um, it interested me for a while, and I decided, okay, I like math and science a little bit more. So I said, all right, let's take a look at the civil engineering thing. So I started, focusing on sort of structural engineering. Then I just realized, hey, I actually like materials even better, right? And that's just kind of how life takes you where you want to end up. Um, see, so if people that say structural engineering sounds interesting, so I can talk a little bit about structures since that's a little bit related to my area in materials. Um, so structural engineers pretty much try and figure out how do you design a building so that it stands up, it lasts a long time, resists earthquakes, resists wind loading, resists all sorts of these things, right? So you have classes in um, concrete structures, um, steel structures, wooden structures, masonry structures, um, and then all sorts of things related to uh, the structure resisting earthquakes. So we do have earthquake engineering courses, um, things like dynamic loadings. So things like vibrations. How does that affect a building? So structural engineers kind of get to focus on a lot of different topics, and yeah, there's a lot you can do there. So we have a question now on: do you need a master's for structural engineering? Um, I mean, yes and no, and I would open that up to more. Do you need a master's for civil engineering? Um, so one of the things that a lot of civil engineers will do is get their professional engineering license. All right. So for instance, I have a PE. I'm licensed by the state of Virginia to practice civil engineering. All right, and that you know if I were in a design firm or something, um, I would need that to be able to, sign off on a design, things like that. Right? You have to be licensed, for your design to carry weight and for people to have confidence in it. So for a while, um, the American Society of Civil Engineers was talking about requiring a master's to qualify for taking that professional engineering license. I don't know what happened to that. I mean, this is something they were talking about when I was an undergrad, right? So we're talking, 10, 15 years ago. Um, so I think that that's kind of fallen to the wayside. But we do have a lot of students will stay for a master's degree. Um, it allows you to have more specialization, additional education, additional qualifications. You'll tend to qualify for more jobs. You'll tend to get a higher pay, which is always a plus. Um, so for structural engineering specifically, um, the answer is no. And I would say for all civil engineering, the answer is no. You don't need a master's. Um, we have students that tend to want to get a master's just to have that additional qualification. So we do actually have a program at VT in our department where, as an undergrad, in your senior year, you start taking a few master's level courses, and then you just stay for an additional year or year and a half to get your master's degree. So it's kind of a dual degree. You get to go and graduate with a bachelor's of science and a master's of science, BS and MS. Um, and so, yes, we do find that in the structural engineering program, we have a lot of students that do that. For the other subdisciplines in the department, I can't speak to that too much since I'm not, directly involved in their programs. Um, but yeah, we do have a lot of students that consider a master's, and most students do really well, right? And then they're also in very high demand, right? We actually have a lot of we for a while we've been struggling to keep our students for a master's, um, because already with a bachelor's they're getting really good job offers, high paying job, good job security, and so they say, why should I stay for a master's? Right? So and that's, I mean, to an extent that's a good thing. That's a good thing that our students are in that high demand. It's a bad thing for us because we want to keep our best students you know to do great things in our department. um, so yeah, it's something to consider. um, but yeah, I don't think you need to have this looming over your head that I have to get a master's. um, in my case, I think I decided senior year. I think it was probably the first semester my senior year. I had decided to get a master's degree. As an undergraduate, I was working for a professor. I was working with some other students, um, and so I approached him. I said, I'm interested in maybe a master's degree. You know, would you like me to stick around? He said, yeah, absolutely. Um, and then at the time, I wasn't thinking about getting a PhD. I was just thinking about getting a master's, and getting a job. Um, but then I found I really enjoyed research. I really enjoyed my project. My advisor at the time strongly encouraged me to stick around for a PhD. And I made that decision probably a couple of months before I finished my master's degree. That yeah, okay, I'll stay for a PhD. So you never know where life is going to take you, I guess. But again, you always want to, find what you're interested in, find what you love, and stick with that. Well, if there's no other questions, I'd like to thank you all for joining today, and I hope you all consider civil engineering.